This is a sample DCG question involving a tetrahedron and an oblique plane. It's out of Folens sample exam papers, and it's sample paper 3, section B, question 1. It's on page 78 of the new papers. You really will need the question in front of you as we go through this solution. We're going to start off there and we're going to draw in our tetrahedron in our plan, which is reasonably straightforward. To get the height of our tetrahedron in our elevation, we're going to need to draw an auxiliary. So note that our xy line here is parallel to this line in our plan, and we carry up our projection lines, which are obviously 90 degrees to your xy line. Note that our axis here of our tetrahedron is contained as a point view in our plan, and it'll be a true length in our auxiliary. So to get the height of the tetrahedron, we'll have to map our true length against our axes. We know that the true length of this line here is 80 millimeters, so you'll scribe that with your compass, and that's going to give you the height there of the tetrahedron. We'll also draw a line from the top of our tetrahedron down to this point here, and that's going to give us the edge view of this surface here. We'll need that later on in the question. We'll draw in our elevation there as we have our height got from our auxiliary. For the second part of the question, we're asked to draw in the oblique plane, given a true length on a surface and a true inclination of 35 degrees to the horizontal plane. We know that A is 45 millimeters above our xy line, so that's going to give us A up here. As we have a true length, we'll need to get a true shape to find that. So we'll get a surface development of this surface here. You can see it here in our SolidWorks model. We're getting a surface development, and then we're putting our true shape on that surface development. Note that your xy line here is parallel to this line here in plan. Note also that this distance here is the same as this distance here in our surface development. It's important to note that this is not an auxiliary, it's a surface development. You carry your line down from your elevation, which is point A, down to our plan, and we bring that up to the surface development. Note that this height here is not the same as this height here, as this is a surface development, not an auxiliary elevation. We're going to scribe an arc there of 36 millimeters, given this is our center point, and that's going to give us our true length on our true shape. We're going to bring that back then to our plan and carry that up then to our elevation. So we have that true length drawn in our surface development, our plan, and our elevation. Quite a difficult part of the question. To draw in our oblique plane, we're going to have to put two cones underneath at A and B respectively. The base angle of the cone is going to be 35 degrees. So you can see we're putting one under A, dropping it down to here to our plan, and we're going to draw in that cone. We're putting another one under B, dropping that down to our plan and drawing it in. So in our SolidWorks model, you can see what's happening. We're putting a cone under the point, and then we'll be sitting in our oblique plane against that. You can see here that your trace is tangential to the two base circles made in our plan. We're going to draw our auxiliary then to show the cut tetrahedron. So you can see there in our SolidWorks model, we're going to be looking in here along our trace. That's going to give us a point view of our trace and an edge view of the oblique plane. So you note that your height here is the same as your main elevation, as it's an auxiliary elevation. We can draw in our tetrahedron, and we're going to carry up point A. Note that A is up 45 millimeters, as this is an auxiliary elevation. We know that it makes an angle of 35 degrees with the horizontal plane, so we can draw that in. We'll draw our cut surface then back in our plan, and we'll draw it in our elevation. The next part of the question asks us to find the true shape of the cut surface. So what we're going to do there is look in at this direction here, and that's going to give us the true shape. Note that this XY line is parallel to our cut surface, and we set up a datum line here parallel to this line here. Carry out our projection lines, and then we're going to draw in our true shape. So this distance here back from our datum line is the same as this distance here. That's going to give us a true shape there of our cut surface. So it's this surface here as a true shape. For the last part of the question, we're asked to get the dihedral angle between two surfaces, which are these two surfaces here. What we're going to do is create two planes on those surfaces, and we're going to get the dihedral angle between them. We set up our first auxiliary there, and we draw our two planes. So you can see this line here is parallel to our line of intersection, which is this line here, and we bring out our projection lines perpendicular to that. We get our heights then from our elevation. To get the dihedral angle, we need to look along your line of intersection here, as it's contained as a true length in your new auxiliary. That's going to give you a point of view of our line of intersection, and that's going to give us our dihedral angle. And that is that question complete.